Hi guys, welcome back to Data Every Day. Today we're looking at a dataset of quality prediction in a mining process. So basically it's a dataset of different attributes about a mining process, and we'll be trying to predict, it says here, the percentage of silica concentrate every minute, which is the last column. And there's also this percent iron concentrate column, which it says, is it possible to predict the percent silica in concentrate without using the percent iron concentrate, as they are highly correlated? So we're going to be doing both of these. So let's start a new notebook, and I'm just going to import these libraries: NumPy, Pandas, Matplotlib, Seaborn, regular expressions, standard scalar from sklearn, and the train test split scalar. Train test split function from sklearn. And then for our model, we'll just be using linear regression, and we'll be training two models, one with the iron column, one without. Alright, so let's get started. So we'll load in our data using the pandas read CSV function. We can get the file path right over here, paste it in, and then we'll take a look at it. And this one I think has like 400,000 examples. It's just taking a second. And 700,000 examples. And you can see everything is in numerical form. Actually, let me make sure that we can see all the columns. Pandas.set option, max columns, none. Alright, now we should be able to load them all in. And yeah, we can see everything is in numerical form, but we have commas instead of decimal places. So we're gonna convert the commas into periods so that the model understands. And then this date column, we're gonna try to extract some new features out of that, such as year and month. So let's get started pre-processing the data. Alright, and actually before that, let's just take a look at some of the preliminary information about the dataset. So it looks like for null values, we're pretty good. I'll double check that. But also for data types, we have all strings. Okay, so data is in a.sum, just to double check that we have 0 null values. And good, we're pretty clean data set. So there's only a few things to do. First, we're going to get rid of these commas, right? So we can do that just by applying a lambda function to each column. So for column in data.columns, data subcolumn will become that same column but with a lambda function applied that takes in some x and returns x dot replace a comma with a period. And that should do the trick. We can just take a look at the data after that when it's finished, and sure enough, all the commas have gone to periods, and this date column has been left untouched since there were no commas in it. Alright, so I think we're pretty much done with pre-processing at this point. There's just one more okay, let's do some feature engineering. And we're going to try to extract two new features out of date. So we can use regular expressions to capture this guy. Here, let me pull up regex 101, and just to give you an example, if we grab a date, any old date, this one, if we wanted to capture just this part, because if we captured that part, we'd be able to snag the year from it, and we'll snag the month from it. The day isn't really, I was probably not carrying too much information. So let's see how we do this. We can say, okay, match anytime you see some string of numbers followed by a hyphen and then followed by another string of numbers. And that the first match here will be exactly what we're looking for, right? So we can use this expression right here in our notebook, and we can say, okay, so data sub date dot apply a lambda function that takes in an x and returns re.search, which is the regular expression searcher. We search in the pattern that we just found, and the thing we're going to search is x. And then we're going to have to do dot group 0 to get the result. And if we look at that, yep, sure enough, now we have the year and month as the new value. So I think it's pretty safe, just for our purposes, to overwrite that column. And now we can find another regular expression. So if we crop it down to what we have now, we can now try to find another regular expression, actually two, one that will get the year and one that will get the month. Now we don't actually have to use regular expressions to get the year, right? Because I mean, we could just index this, right? They're all in the same format. But just to give us a bit of a challenge, let's find a way to do that. So starting at the beginning of the line, any character that isn't a hyphen, any number of times. No, that's not. Oh no, sorry, this is not beginning of the line. This is that one does it. So that will get us the year, and then if we do the end of the line, we'll get the month. So it's these two, right? First with the caret at the beginning, and with the $sign at the end. So this will be the year one. So data sub year, we're making a new column here, is going to be, here I'll just store the expression there. We're going to grab this same line, but we're going to change the expression to be this. And now this date that it's applying is the updated version. And then we're going to go back and we're just going to change it so that we can get the month now. And we'll do another one, which this one we'll put in this guy, and this will be month. Alright, let's run that. And then we're going to drop the original date. Alright, we take a look at data, and we can see date is gone, and at the end we have a year column and a month column. So at this point everything is in numerical form. We can say, here, let me just put all these in the same, put all these in the same block just to make it nice. Okay. And okay, so let's turn it into floats. Because right now it's still actually strings. So data equals data.asType numpy.float. Alright, that should do it. Same thing, but now everything is floats. And now we can actually work with the data. So why don't we visualize it a little, just to get a heat map, right? So visualization. And so we're gonna make a new figure. Fig size 12 by 10 will do. sns.heatmap, seaborne heat map. And we're gonna use the correlation matrix here. And let's just specify the minimum and maximum color values that we can get. Oh, this should be -1. Alright, and then plot.show. And we can see, there's one thing that's striking me here, is that year is all white. which suggests that maybe there's only one value in year. So let's check year.unique, and sure enough, there's only one value. So we're just going to drop it. That was not helpful. Getting year, although it was a good pursuit, looks like not carrying any more information. So data.drop year axis 1. Oh wait, data equals. Okay, look at data. Everything should be good. Let's just take one more look at this heat map. Start up here, and looks pretty good. Our predictor is this one here, right? Silica concentrate. And there's nothing that's too correlated except for this iron concentrate, which it has a very strong negative correlation. And like it said here, they are highly correlated. So we're going to train a model with silica concentrate. We're going to train a model on the dataset without the iron concentrate column, and we're going to train another model on the dataset with the iron concentrate column and see if we get an improvement of the results. So now that we have our numerical data, we can apply. We can try splitting and scaling the data. So y is going to be our well, let's say target is going to be this guy, percent silica concentrate, and then our y will be data sub target, and we'll make two x's, one xn for x no iron. This will be the dataset without the iron, so data.drop target, and it's percent iron concentrate. And then xi, which will be x iron, will be data.drop target to specify the axes. Alright, now y should just be an array, a vector of silica concentrate values. Xn should be the dataset without the iron concentrate, and xi should be the dataset with the iron concentrate. Alright, so now let's split it, let's scale it, right? So a scalar, let's use the standard scalar from sklearn, and we'll just apply that to both of our x's. So xn equals scalar dot fit transform xn, and xi equals scalar dot fit transform xi. Alright, and then we'll do xn train, xn test, yn train, yn test equals train test split xn y, and train size will be 70%. We can do the same thing here, except we're just going to grab all these n's and make them into i's. Alright, and so now we're ready to train. So training, we're going to make two models, model n, and that will be linear regression, and then model I will be the same thing. So we'll train model n dot fit xn train on, we're training it on the xn train, yn train, and the reason that I'm using yn and not y, like why I split it between these two, is because this will randomly shuffle the data. So if we tried to use the same y for both, it would not work out. And then we can get the score of xn test, yn test. What's model n? and we get an r² value. Here, let me print that. Model without iron. r² score. And yeah, so about 0.15. Let's just see if we get an improvement if we do the same thing but with the iron. So this will be model I, and we'll be fitting on xi train, yi train, and scoring it on xi test, yi test. What happened? Let's look at the shapes. What, is there a problem here? Well, let's see. Is this the problem? No. It's the... Oh, I'm trying to score it. Look at this. Okay. Model I.score. Alright. And we get a much better result. Look at that. Alright. So, what do we learn is that it looks like the iron really helped, and that's to be expected, right? Because there's such a high correlation there. Alright, that wraps up today's video. Thank you so much for watching. If you enjoyed, make sure to subscribe, hit the bell, and leave a comment in the section below. I'll see you guys tomorrow. Have a great day.